Welcome to our lesson on the unit circle and trig functions. We're just going to review the basics of what a unit circle is and the big six trigonometric functions and their basic properties and where they lie on the circle. Let's start with reminding ourselves of what the unit circle is. It's just a circle that is centered at the origin with a radius of 1. And of course that is the formula for a circle of radius 1 centered at the origin. Circumference, right, the distance around the outside of the circle is always 2 pi. So that means this red line, if you were to cut it and lay it out flat, would have a length of 2 pi units. Now symmetry, of course, that's only because we're on a unit circle, right? The general definition for circumference is 2 pi r, but because r equals 1, we just get 2 pi. Okay, also because we're centered at the origin, we have all this lovely symmetry where this point here has the exact same x distance, right, in both directions, only this is positive and this is now negative. And then this vertical distance is also the same down here, right, positive and negative. And so you can get 4 points that are relatively the same values, just with different signs. All positive, all negative. One's positive, one's negative, one's negative, one's positive, right? Okay. That'll help us out later when we're trying to memorize these trig functions, because instead of having to memorize what they are in all 4 quadrants, all we have to do is remember what they are here in quadrant 1. We'll talk about reference angles and things being in the first quadrant. An example, figuring out if a point is on the circle, and if it is, we can find all of its symmetrical points. Well, if a point's on the circle, it just has to be a solution, right, to this equation. So plug it in, do the math, and go, yep, that works. Now that we know that this is a point on the circle, we know that we have all 4 combinations of it, this one plus the other 3. All the same numbers, you're just swapping out the plus and minus signs. How about if we want to find all the points on the unit circle that have the y-coordinate of 3/5? If you go back to the picture, it's kind of this idea of draw a horizontal line at the height y equals 3/5, sorry, 3/5, not 3/4, and then find these 2 points. Well, if those points are on the circle, those points are solutions to the equation. You plug it in, you square it, you move it to the other side, you combine them. Now you've got x squared equals this. Take the square root, remembering that when you take a square root, you get plus and minus, so you get plus and minus 4/5, and there are your 2 points. Nice and simple. Okay, what if we want to define some trigonometric functions? Sine, cosine, tangent, cosecant, secant, cotangent. Now I know that they really messed up the naming protocols with these. Tangent and cotangent's really easy, but sine to cosecant and then cosine to secant, that can get a little tricky, a little difficult to remember. But as long as you can remember the relationship between these 6 functions, knowing that tangent is just the ratio of sine over cosine, right? See how it's y over x? That means tangent just equals sine over cosine. And since cosecant is 1 over y, that means cosecant is just 1 over sine. And similarly, since secant is 1 over x, it's 1 over cosine. And then, of course, cotangent is 1 over tangent, which is also the same thing as saying cosine over sine, right? Because 1 over this thing, you just flip the fraction. So that tells us that all 6 of these things are really just related to sine and cosine. So as long as you understand sine and cosine and you can figure out values for sine and cosine, you can always figure out values for the other 6. Because if I know sine of t equals, let's say, 3, then I know this one's 1/3. Right? And then if I know cosine of that same t happens to be 2, then I know this is 1/2, I know this is 3/2, and I know this is 2/3. And I don't have to memorize anything other than their relationship to sine and cosine. It's very helpful that way. When we're dealing with cosine and sine, something that can help you is visualizing the unit circle. Draw a picture of the unit circle each time you're dealing with these things, and then figure out what's going on. Cosine is just a measurement of your horizontal distance. Remember, cosine was defined as x, right? Cosine of t equals x, so it gives you the horizontal distance, whereas sine gives you the vertical distance. So now when we have a point xy, right, every point on the plane has coordinates xy, so every point on this circle also has coordinates xy. But we can also relate those points back to cosine and sine and write them as cosine comma sine of t. What is t? T is this distance here, this length, this arc length. But isn't an arc length also an angle? Right? We have an angle that creates an arc length. So we can actually list cosine and sine as measurements of both this length and this angle, because this angle will also determine that same point. If we're at this angle, we hit that point. And that's why your calculators can calculate sine and cosine in both degrees and radians. What if we want to try and find exact trigonometric values? You know, what is the exact value of sine and cosine at a particular point, or cosecant, secant, and tangent for those matters? How about these 5 examples? When t equals 0, pi over 2, etc., 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 can we find specific values for our functions? Well, you'll notice before we move on that when t equals 0, we're here, right? When t equals pi over 2, we're here. That's 90 degrees. When t equals pi, we're over here. When t equals 3 pi over 2, 1, 2, 3, right? 3/2. And then finally, when we're negative 3 pi, we go 1 pi, 2 pi, 3 pi, and negative 3 pi is the exact same thing as positive pi. So we're really only solving 4 things, because once we know the answer to C, we already know the answer to E as well. Okay, let's take the first one. When t is 0, and we can look at our picture down here, right? When we're over here at 0, our x distance is 1, our y distance is 0, right? 0, 1. So therefore the rest are defined by those. Y over x, right? 0 over 1. Cosecant, which is 1 over this, we get 1 over 0, which is undefined. Secant, right, is 1 over x, so we get 1 over 1. And then cotangent, which is 1 over tangent, we get 1 over 0, which is also undefined. Do the same thing for the next point at pi over 2 when we're up here at the top. We can see that our y distance is 1, but now our x distance is 0. So sine is 1, cosine is 0, and all the rest are built off of those. So you see, you no longer have to worry about memorizing 6 answers. You just have to know 2. And then the other 4 come from their relationship to sine and cosine. Our third example, when we're over here at pi, right? X is negative 1 and y is 0. Build the rest from that. Next, when we're at 3 pi over 2, down here at this point, right? X is 0, right? We haven't gone left and right at all, and then y is negative 1. Build the rest off of that. And then our last one, which as we already saw was the same as pi, we get the same answers we got for pi. Okay? And then here's a summary circle. You can a lot of students print these out or make their own copies, and it's a nice little reminder of just some of the basics. We only covered these dots, right, the ones that are on the axes, but later on we're going to see that we do a lot of work with these special angles, 30, 45, and 60, or pi over 6, pi over 4, and pi over 3. And these are the x and y, right? These are the x and y coordinates. So these all represent a cosine and a sine measurement. You go over a half up to square root of 3 over 2, or you go over square root of 2 over 2 and up square root of 2 over 2, which makes sense because a 45-degree angle cuts these things in half, so you're going to have the exact same measurement in both directions, left and right, if you create a nice little right triangle. So something like this can be very helpful, but you don't need all four coordinates, or sorry, all four quadrants, because you can see these three numbers just get repeated. Same pairs, but different positives and negatives. So really just concentrate in that quadrant. And that's all you need to know for the basics of trig functions and the unit circle.